think I need to just read out the number. Okay, so I hope that you are doing good. So we want to talk about a new topic in this chapter, which is the very exciting topic of combinatorics. Of course, it depends what makes you excited, yes. But this is a very interesting and simple lesson, not very hard lesson, but the starting, what I want to talk about is the product rule, yes. So essentially, product rule is that I have 5 boxes. In each box, I have 3 marbles. How many marbles do I have? So how many? Is that hard? 50, yes. So that's called the product rule. So as simple as that, yes. But yeah, believe me or not, this is like pigeonhole principle. Yes, we started with a very simple argument, and then we started solving much more harder problems. And I think one of the hardest problems in mathematics is using effectively this product rule, and of course counting things. Okay. So, of course, counting is not very strange. We know how to count things. If you have, for example, a number of apples, you know how to count them. But, for example, if I give you this question, we will solve this question a little bit later, either this session or the next session. If I ask you how many 4-digit numbers are there which are greater than this number without any digits repeated. Okay, so then I want to tell you that more or less the same ideas of the product rule and another rule that I will talk to you even more simpler than that, the sum rule. Yes, if I have 2 apples and 3 bananas, how many fruits do I have? 5. As simple as that. These 2 will help us to be able to count this number. How many 4-digit numbers are there which are greater than this number and there is no digits repeated? Of course, this is not a hard problem to understand, yes. At the end of the day, you can sit down, be patient, write all of them, and start counting them by one by one. But that's the whole goal of combinatorics. We want to come to an answer without writing all of them and counting them. Yes. So we want to count without counting. Yes. That's the point. So I would say that this is not that trivial now. Yes. You need to think a little bit about, okay, how can I calculate the number of desired numbers without sitting and writing them and counting them. Even though what I'm trying to say is that even though this problem is very simple to state and even very simple to understand, yes, but it is time consuming if you want to start writing all of them and then counting. Of course, you can write a computer program to do this for you, okay? But if you know combinatorics, you can also make your code more efficient. Yes, that's what I'm saying. Is that clear? That's the goal of this lesson. So counting without individually counting. Okay, even though I told you that the product rule is exactly like this, I have 5 boxes, 3 marbles in each box. How many marbles are there? 5 times 3. Okay, but let me write it in a more elaborate way so that it can be useful for our purposes here. Okay, so at the end, either this session or the next session, you see that you can easily count this number. You can answer this question without actually counting them. This is one example. But what I want to say is that these problems could be extremely hard. Okay, so but you don't need to be worried about that. So you need to work on what I'm telling you and then solve the examples in the book. But I want to tell you that this part of mathematics is actually very, very hard to do research. You need to be very smart to find a very shortcut and actually come to a very new idea how to count something. Okay, it's very powerful. We just want to scratch the surface of this very exciting and active topic of mathematics, combinatorics. So these things that we are talking about, the product rule, how to count them, they are gathered under the title of combinatorics. Okay. Well, let me read this product rule for you. So consider a task whose accomplishment can be broken down into two stages. If the first stage can be done in n sub 1 different ways, and if after the first stage is done in any one of these in one ways, and this sentence is very important, independent of how the first stage is done, the second stage can be done in n2 ways, then the task can be accomplished in n1 times n2 ways. Yes? So is that clear? So more or less, if I have a task that can be accomplished, so let me just write you an example. So for example, assume that you want to set up a team of a mathematician and a physicist to do some project. Okay? And for this you have 5 mathematicians. They have registered their names. And then you have, for example, 3 physicists. 3 physicists, yes? So my goal is to set up a team consisting of 1 mathematician and 1 physicist to work on a project. Okay? So this is what is the task here. What is the task? Just try to write it down. Yeah, what is the task? No, what is the task? The task itself. Yes? Yeah, setting up a team. So the task here, this is very important, even though if you are lazy not to write them, don't be lazy not to think about them. Yes? Think about them. You need to understand what is your task, and you need to understand which stage you call stage 1, which one you call stage 2. After that, you can immediately understand, is the product rule applicable to that situation? If that is a yes, you can use this product rule to answer that. If this is not no, you need to know that you are not allowed to use it. Blindly using the product rule. I know that you don't have any idea what's going on right now, but you need to trust me on that. If you don't pay attention to these details, these problems can be very hard for you. Okay, so try to conditional your brain, make your brain conditional in this way that I am talking about. So here, I would imagine, what is the task? You can just write a simple sentence in front of it. So setting up a team. Okay, so you need to have an idea, okay, what is your task here? Okay, can this task be broken down into 2 stages? Yes?
Selecting a mathematician and selecting a physicist.
Yeah, exactly. So I can break it down into 2 stages. So I can write stage 1, selecting a mathematician. Yes. And then stage 2, selecting a physicist. Okay, is that clear? So my task is setting up a team. I can break it down into 2 stages. Stage 1, selecting a mathematician. Stage 2, selecting a physicist. Of course, you might think, can I reverse it? Yes, you can. For example, these are very important things, by the way. I will talk about them. So you might say that, okay, no, I don't want to select this. I don't want to have my first stage selecting a mathematician. I choose a stage 1 to select the physicist. Okay, but this can also be done. Let us keep it for the time being. So is that clear? But what is important? The important thing is that when this task is accomplished, finalized, this task is finalized after both of them are finalized. So if I just do the first step and do nothing, this is not finished yet, yes? Because I have chosen the mathematician, but my task is not accomplished, because my task is to set up a team consisting of 1 mathematician and 1 physicist. These are the things that I want to get used to this. I want to tell so that you can get used to this. So you see that if I want this task to be accomplished, I have to finalize these 2 stages. Then I can claim that this task is accomplished. Yes? And now I am asking you, in how many ways I can do the first stage on these conditions. 5 mathematicians are there and 3 physicists are there. So how many ways I can do the first stage? Yeah, just say something, it's very clear.
5.
Yeah, 5. So this means that the first step can be accomplished in 5 different ways. Yes? But for the second stage, you have to be careful and respect these set of words here. Yes? Okay, so this is very important. So if I ask you, tell me in how many ways I can do the second stage, can you give me a number here? 3, yes? This is important. When you want to write 3, do you depend on the information that the first task is done in which way? Yes, this is important. So when you want to write 3 here, I am telling that in the first stage, any one of these mathematicians might have been chosen. Yes, so mathematician 1, mathematician 2, mathematician 3, mathematician 4, or mathematician 5. Okay. For writing this number 3, do I really need to know in which way this task is done, this first stage is done? Yes or no?
No.
No, because if mathematician 1 is chosen, okay, I can choose still 3 physicists, each one of them. Physicist 1, physicist 2, physicist 3. And it doesn't matter if I have chosen mathematician 2 in the first stage, it's still how many different ways I can choose the second one. Again, 3, yes? P1, P2, and P3, and the same thing, P1, P2, and P3, and the same thing here, and the same thing here. Yes? So if that is the case, so this, for the first one is usually not hard to count, but for the second one, you need to be careful because sometimes the product rule is not applicable. You need to recognize that, okay? When this is applicable when this number that you are supposed to write as the number of possible ways for doing stage number 2 is independent of how you have done the first stage. So be careful about these words. The number of ways that I can do the second stage is independent of how the first stage is done. Is that clear? It is very important to understand. If that is the case, then if I want to answer this question, so I hope that you agree that now this product rule is applicable. So what I can do, I can write the total number of ways. So the answer, the question mark is just simply n1 times n2, which is 5 times 3, which is 15. Yes? So the answer to this question is very, very simple, and that is 15. It's exactly like that. I have 3 boxes, 5 marbles in each box, and I want to know how many marbles are there. Is that clear? Okay, do you think that I can reverse these 2 stages here and get the same answer? Let us check. If in stage 1, I select the physicist, in stage 2, I select the mathematician, and then first stage can be accomplished in 3 ways. And then when I come to choosing a mathematician for the second stage this time, the number of ways that I can do is independent of how I have done the first stage. Yes? Again, the same story, but this time what you answer is 3 times 5, but again, the answer is 15. So it is not important here which one you want to choose first and which one you want to choose second. Is that clear, the idea? And the idea is very clear. So at the end of the day, so if I want to list all possibilities, what are the possibilities of this team? Yes? How can I write this? For example, I can say that I choose mathematician 1 with physicist 1. This is one possibility, yes? Or I choose mathematician 1 but physicist number 2, yes? And then I can continue this list. I want you to understand what you are counting from abstract point of view, yes? So you are actually counting the number of ordered pairs somehow, in which the first component is a mathematician and the second component is a physicist. So in abstract level, what you are counting is the number of these ordered pairs, yes? So, and then, for example, if you continue this list, you will reach to this point that you have mathematician 5, and which one, for example, physicist 3. And what I counted here as 15, it means that if I am patient enough and write all these possibilities and start counting them, that would be 50. Is that clear? Okay. So I will repeat this sentence over and over again so that it will be in your brain. Okay. So, but before that, let me just give you another example to appreciate what I am telling you here more. Okay. So, for example, let me give you this example. Change this. Okay, so now let me give you another example. Assume that you have two cities. Call it, for example, city X, and I have another city called Y. And then assume that there are 5 roads connecting these two cities. Okay, so one road, I call it road A, and then B, and I don't know, C, and D, and E. Yes. So 5 roads are connecting them. So in how many ways I can go to X and return back if I am not supposed to choose the same road for return as the road that I chose for going? Okay, so this is the question clear? I want to start from X, go Y, do something there, might be come back again to X. But there is one condition. The condition is that I don't want to choose the same road for the return trip as I chose when I was going there. So then I want to see in how many ways I can do this. Okay, this is also a very simple problem, but let me try to write it down. Okay, so first of all, if you want to apply the product rule, you need to have a task. So what is the task here? So I don't want you to write it down, but I really want you to think in this way. Because when the problems get harder, then it would be very confusing. You need to trust me on that, okay? So here, what is the task? Yes?
Deciding on a route.
Deciding the roads under these conditions, yes? Deciding about roads, the roads for this round trip. Okay, you don't need to make it long, but at least you have some idea. Now, can this task be broken down into 2 stages? Yes, because it is very clear it's 2 stages. So what is the stage 1? So there is a natural order here. Yes, in that case, there was not a natural order. But in this case, you have to go first to Y, then decide to come back. Okay, so it's better to write stage 1 is selecting the road from X to Y. That's X to Y. It's better. This is the first stage. And then after the first stage is done, I can think about another stage. Stage number 2, I can call it selecting the road from Y to X. Okay? But this is important. When this task is accomplished, if I just do the first stage and don't do the second stage, it is not done yet. These are important things that you need to imagine. So stage 1. In how many ways I can do stage 1? So here you see N1 is how many ways? Yeah, it's simple. You can just shout it. Yes, how many? 5. Yes? But when I go to N2, what number can I put here? And then you need to be careful. Is this number that I am putting here relies on the information from the first stage? If the answer is yes, then it means that you are not allowed to use the product rule. If the answer is no, you write that number and simply multiply them using the product rule. Okay, so what number should I write here? Yes, what number? Anyone else? Yes?
4.
4. Yes, is this 4? Is this number 4 independent of how I have done the first stage? Is it or not? Be careful. The number. I am not saying the task itself. Of course, the task depends on task 1. Yes, because if I have chosen road A to go, I am not allowed to choose road A again. So there are some actually effects there. Yes, but this number that you want to put here doesn't need any information from how you have done the first stage. Yes, because you might say that might be in first stage I have chosen A. When I want to come back, how many options are available for me? 4. What are those options? Those options are B, C, D, and E. Okay, but if I choose B in the first stage, how many options are available for me again? 4, but of course these are different. I don't care. I care about this number. If this number is independent of how I have done the first stage, it means that you are on the safe side and the product rule is applicable. Is that understandable? So it means that I can safely write 4 here. Okay, so here I go from A to, if I go from A, so let me choose for, if I want to draw a diagram, this is a tree diagram. Okay, so I might choose how many ways here? A, B, C, D. Okay, A, B, C, D, and E. If I have chosen A in the first stage, how many choices are left for me? B, C, D, E. Yes? But if I have chosen B, how many choices are left for me? Again, 4, even though these are different. So here I can choose A, C, D, E. If I have chosen C, again, 4 options is available for me. A, B, D, E. So you see, this is under actually the influence of the first one because of the nature of the problem. But the point is that the number of branches that are coming out is always 4. Yes, so I have 5 branches first, and for each branch I have 4 branches coming out, even though the names of the branches might be different from case to case. In the product rule, this is not important. The important thing is the number of branches coming out, and that's clear. Yes, because you want to use the product. Okay, so this, if I want to answer this, what is the answer? It is 5 times 4, it is 20. So I can have 20 options available if I want to do something like that. Okay, now let me, to make sure that you understand this, let me make 2 of these roads one-way road and try to answer this question. This will help you to understand what would be the result then. Okay, so you will see that. Let us see how it goes. Okay, so let me make the first 2 roads a one-way road. So it means that, for example, now assume that this road is one way from X to Y, and this road is also one way from X to Y. So definitely you are not allowed to choose them for return. Okay, so let me solve the problem. If I want to solve this problem, I need to set up the task in my mind again. So the task, I can write the same thing. Do you agree? I don't need to change anything. The task is still deciding about the roads, the road that I choose for going and the road that I choose for coming back. And then stage 1 is selecting the road from X to Y. Stage 2 is selecting the road from Y to X. Okay, now let me clean these numbers and ask you what's happening here. What is the number N1 now? I am in X, yes? It's still 5. Do you agree? I want to go from X to Y. How many options are available? 5. But now, how many options are available for N2? Let me, everyone thinks a little bit about that. So I want to, can I write a particular number here? Or you would say it depends. If you say it depends, it means that, okay, the product rule is spoiled. You are not allowed to use it. If you say this number depends on how I have done the first stage, then it means that product rule on its own is not enough to answer this question. And of course, this question is so simple, you don't need to know anything. You definitely can answer this. But hopefully everybody agrees that I cannot write a particular specific number here, because let us see how this diagram will be affected this time. If I have the first 5 options available, yes? If I have chosen A in the first stage, how many choices are left for me in the second stage? Yes? 3. C, D, and E. Yes? So it means that from here, I have 3 branches coming out. C, D, and E. What about B? How many options are available? Again, C, D, and E. Do you agree? So this is. But if I have chosen C, how many options are available? Yes?
2.
2. Yes? Because A and B cannot be chosen because they are one-way road. C has chosen, so I am not, according to the problem, I am not allowed to choose it again for returning back. So how many options are available? 2. So it means that I can choose D and E. So you see the branches are changing. The number of branches coming out are changing. And if I have D, of course, then I have C and E. And if I have E, I have C and D. Okay? So the answer is not 5 times 4 or 5 times 3. If you write each one of them, it is wrong. But of course, you know what's the correct answer? You have 3 of them. You have 3 boxes. In each box, you have 3 marbles. And you have 2 other boxes. In each one of those boxes, you have 2 marbles in each. So then how many marbles are there in total? You say 2 times 3. And then you write 3 times 2, and then you add them. Yes? So this is, I will talk a little bit later about, that is the sum rule. So what I'm telling is that be careful, even though everything seems very trivial right now, but trust me on that. If you will continue and don't think, okay, if you are lazy to write, don't be lazy to think in this way. You need to have a very clear understanding of what a task is. You need to have a good understanding of what are the stages. The stage 1 is usually easy to write the number. For writing the number in stage 2, you need to ask these questions. Then this question from yourself: is the number that I am putting here depends on how I have done the first stage? If the answer is yes, it means that be careful. The product rule on its own is not applicable. It's not useful to solve this problem. Is that clear? So hopefully you understand what is going on. So by that, independence. That's very good. So the answer to this question is, of course, 12, but I will come back to this later. Okay, so are you ready to solve some problems? So for example, let me give you some very simple examples. Even though they are very trivial, but I want you to solve it using the product rule if possible. Okay? So example. How many 2-digit numbers are there? Of course, this is a simplest possible question, but I want you to use the product rule to answer these simple questions. So how many 2-digit numbers are there? Can you just tell me without calculating anything? Yes?
100.
No? 2-digit numbers. What?
20.
What?
20.
No, 2-digit numbers. For example, 25, 33. How many 2-digit numbers are there?
89.
No? Yes?
90.
Right, it's 90, yes. Because you also count 9 and 10 and 99 at the end. Yes? So 10, 11, 12, 13, you need to count them. Yes? How many 2-digit numbers are there? 90. Okay? It's not hard. But let us see how I can use the the product rule to answer this question. Don't be in a hurry. You need to think about what is the task. Can you cook up a sentence for your task here? Yes?
One, select the first.
No, task. The main task. What is the main task? If you want to think it in that format, yes? You need to have a task. What is your task? What is your duty here? Are you sleeping? Yes. Yeah. Yes?
Create 2-digit numbers.
Write a 2-digit number. Yes, something like that. Just cook up a story in your head. Yes. So task, writing down a 2-digit number. Okay. So which one do you want to choose as a stage 1? If you really, do you understand that? If you really, because when I ask you write a 2-digit number, this is very good, by the way, to think a little bit about yourself. When I ask you to write a 2-digit number, immediately you can do that. But if you think wiser, you are actually deciding about 2 things. Yes, you are deciding in your brain about the digit on the left and about the digit on the right, but you do it so quickly and automatically that you don't even recognize that you are doing that. Yes, when I ask you to write a number, I write 23, but I decide about 2 and 3. Yes. So in this way of thinking, can I break down this task into 2 stages? Yes. Yes. Stage 1.
The first, choosing the first digit.
The left digit, for example. You mean or no? Stage 1. This is the natural one because we usually write numbers from left to right. So it's better to choose this. It's not always the case. Sometimes changing the order makes it clear, that makes it possible to solve. Okay, be careful about that. I will come to this. Stage 1. What is a stage 1? Writing down the left digit. Okay, but is the task accomplished here? No. I have to accomplish it in 2 stages in this way. So writing down the right digit. Okay, so this task is only accomplished if both of them are accomplished. Yes, if I just do the second stage, it means that I have 1 digit on the right. I have to have both of them. Okay, now can you tell me how many ways I can do stage number 1? No one? Yes, please.
9.
Stage number 1, 9. Do you agree? Because I cannot choose 0 on the left-hand side. If I write 0 and 1, if I ask you how many digits are there are only 1 digit. Okay? So this means that N1 can be done in 9 different ways. What are those ways? Choosing 1, choosing 2, choosing 3, up to choosing 9. Okay? And then how many ways I can do the second stage? Yes? 10. When you want to write this 10, you need to be a little bit careful. Is this number 10 independent of how I have done the first stage or not? If the answer is yes, you can write it and make sure that the product rule is applicable. Is this 10 independent of how I have done here? What do I mean? If I have chosen 1, how many choices I have here? From 0 to 9, which is 10 digits, yes? If I have chosen 2 here, still how many choices I have for this one? I have 10. So it seems that this number 10 is independent of how I have done the first stage. So everything is clear. So according to the product rule, the question mark is 9 times 10, which is 90, and it actually squares with what we predicted before calculating this. Is that clear? Of course, this is the natural order, but let me ask you, if I interchange these stages, let me choose a stage 1 to choose at the right digit, and the stage 2 choosing the left digit. What will happen then? Do you think that this is possible or not? So stage 1 is choosing the right digit. Then how many options are available for stage 1? The right digit. 10, yes? And how many stages are there for the second one? 9. This 9 is still independent of the choices here. So the answer becomes 10 times 9, but again, the answer is 90. Is that clear? Okay. Now, let me ask you this question. In how many of them no digit is repeated? Of course, it is easy to answer this question, but I want you to use the product rule if possible. For example, if I want to calculate it naively, I can say that how many ones I don't want to be there? 11, I don't want it. Yes? The other one that I don't want is 22, and then 33. These are not the one that I want. So it is how many of them are left then? Yes?
81.
81, yes? Because 11, 22, 33, up to 99, there are 9 of them which have the repeated digits. I don't want to have them. I know the total number is 90, and I subtracted this, then it becomes what? 81. So that is a complement rule. I will talk about that. But let us talk about the product rule. Can I answer this question only using the product rule? So the question is the same. I want to write down a 2-digit number, but I want to make sure that the digits are not the same. And I want to use the product rule if possible. So think about in this way again. What is your task? Task is again writing down a 2-digit number with distinct digits. Okay? So the task now is changed. What is a stage 1? I can write it as stage 1 again, a stage 2, and then let us see. How many options are available for a stage 1? Yes?
9.
For stage 1, it's 9. Because why you write 9? Because 0 cannot be chosen. But how many options are available for N2? Yes?
9.
Again, 9. Do you agree? But is this 9 independent of how I have done here? This you need to check, even though this is trivial, but I want you to train yourself in this way so that you can check it. Let me just be careful and check it. So here, the digits that I have is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yes? Okay, the first one I have 9 options available. I can choose any one of these numbers except this one. Okay, that's good. But let us do this stage with in one way. For example, let us choose 4 in the first stage. And then I go to the second stage. Okay, I want to choose a number for the right-hand digit. Which options are available for the second one? Am I allowed to choose 0 for the right-hand? Yes. Am I allowed to choose 4? No. According to the problem, no. So how many options are available? 9. But check this, 9. Is it important if in this first stage I have chosen 6? Yes? Assume that I have chosen 6. How many numbers are there for second stage? Still 9 of them. So it seems that this 9 that I am writing here is independent of how the first stage is done. If that is the case, you can use the product rule. Yes? So the answer to this second question, as you predicted in a different way, is 81. Yes? Is that clear? Okay. Now let us go to the next example.
Mr. Baba,
Yes?
is it also worth pointing out that if we reverse the...
Yeah, that's the point. I want to talk about this. That's a very good thing. Do you remember in the previous problem that I had it on board without these distinct digits, even though this is the natural order that I choose for accomplishing this task because I write from left to right, but I just convinced you that if I interchange the role of these two, it does not change the result. Yes, it becomes the same. Is that understandable? That was the. Now I am asking the same question, even though it's unnatural. But can I interchange these stages? Can I write this stage 2? Can I write this stage 1? let us consider this scenario. Okay. Okay, now I want you to answer me. So here I would call it N2, here I would call it N1. Can you tell me what can I write in front of N1? My problem is this problem with distinct digits, but writing down the right digit is the first thing that I want to do. How many options are available here? Yes?
10.
10. Without thinking, 10. I can choose any one of those numbers here. But now let me go here. What can I write here? Yes, please.
Theoretically 9, but if you choose, I guess you can put that later. But if you choose 0, then it's.
Oh, you are right, but theoretically 9 is wrong. What you are saying is correct, but your conclusion is no. Even theoretically, we cannot write something like this. Yes. Yeah, exactly. But what you are saying is completely correct. You should say that the number that I want to put here depends in a way that I have done the first stage. Yes, let us check. Why this depends? Because it is completely possible that in the first stage, when I write 10, I have chosen 9. It is possible. But now for stage 2, I am going to choose the left-hand digit. According to the problem, I am not allowed to choose 9 because it is not going to be repeated. But I myself know that I am not allowed to choose 0 either. So how many options are available? 8. So in some scenario, this might be 8. But it might happen that I have chosen 0 in the first stage. Yes? And then how many options are available for me now? 9. So you see, this depends. When this depends, it means that I am not allowed to use the product rule. I hope that these simple examples is enough for you to understand what's going on. Yes? It doesn't mean that we cannot do it if we want to do this, but I need to count 2 different categories and add them together. Okay? But of course, so you see, it's very important to understand this point, that sometimes changing the order of stages is also very important. Yes? Is that clear? Usually, my experience is that start writing the first stage with that one that you have more limitations. I don't know, this is just a rule of thumb that I have discovered myself. This is not always true. It's not a mathematical argument, yes? So if I want to write a 2-digit number, which one of these digits have more limitations? The left-hand side digit, yes? Because the left-hand side digits cannot accept 0. But the right-hand side digit doesn't have any problem with that. So if that is the case, this is my advice, that use that one as a stage 1. This makes it a little bit easier, okay? Is that clear? So we learned about that. This is also crucial sometimes. If you interchange the role of stage 1 and 2, most of the problem doesn't change. You can solve it. But if you sometimes change depending to the problem, then you are not able to use just the product rule to answer the question. Okay. Any questions here? Okay, let me just make another simple example. How many, of course you know the answer, how many 2-digit numbers are, how many odd 2-digit numbers are there? Odd 2-digit numbers, 2-digit numbers. The number of odd is what? Of course, you know immediately the answer. What's the answer?
45.
45, yes, because there were 90. It's clear 45 of them are even, 45 of them are odd, so it's clear. But let us do the product rule again if possible. And by the way, don't ask me, am I allowed to repeat the digits or not? What do you think? Are you allowed by just reading this sentence? Because I know that everyone, and then in the exam you will ask, okay, am I allowed to repeat it? But what you read, you need to trust. Yes, odd 2-digit number. Do you agree that this is an odd 2-digit number? Yes. So it means that you automatically know that the repetition of the digits are allowed. Yes, is allowed. So here, can you answer me through the product rule? Again, repeat it in your mind, but let us not write it. What is the task? What is the task, everyone? Writing a two-digit odd number. This is the task. This task can be accomplished in two stages. Stage one. Okay, so let us just write. Which one do you want to choose? The left hand. Okay, left one. You know what I mean. So what is n1 here?
9.
It is 9. Yes, because the only one that I cannot put on the left hand side is 0. So you say it is 9. Okay, but let us go to stage 2. I need to choose the right one. What is n2? Be careful. You want to write an odd number. Yes, Kulu? What? 5. So which one do you want to choose for here? 1, 3, 5, 7, and 9. These are the options available. But when you want to write 5, just think a little bit. Is this 5 that you are answering depends on how I've done this? You need to convince yourself. You don't need to write it in the exam, because if your answer is correct, that's okay. But if the answer is wrong, you cannot detect it if you are not thinking in this way. Okay? When you want to write this number, make sure that this number is independent of how the first stage is done. So that's clear. So what's the answer? 9 times 5. And the answer, as you predicted, is 45. Is that clear? Now let me answer the same question, odd two-digit numbers with distinct digits. Just think a little bit about that. When I am cleaning the board. Okay, so now odd two-digit numbers with distinct digits. Okay, now which one do you want to choose as a stage 1 and which one do you want to choose as stage 2? Let us keep it in this order, at least. According to my advice, I think we need to reverse that, yes? Because for the left-hand side, what is the limitation? The only limitation is 0. But for the right-hand side, we have more limitations, yes? We cannot put 0 because it becomes even. We cannot put 2, 4, I don't know. Let us check if it works here. Let me just first try to do it in this way. Stage number 1 and stage number 2. Okay, can you tell me what is the number of ways that I can do stage number 1? Yes?
Still 9.
It's still 9. It doesn't matter. But can I write something for N2 here? It's clear that it depends, yes? Because here I'm not allowed to repeat. You might say that it is possible that in the first stage, I am choosing this number. Okay? Because I am not allowed to repeat, I have to go and choose something among these numbers. I want to choose the right one. So how many options are available for me? Be careful, I want to have an odd number. So 1 option, 2, 3, and 4. Yes, I can write 4 here. But is this 4 is always the case? No, because it might happen that I have chosen 0 in the, no, the left-hand side cannot be 0. It might happen that I have chosen what? 2. Yes? Then how many options are available for this one? 1, 2, 3, 4, 5. So it is 5. Yes? So it means that in this order, even though it seems natural order, I write from left to right, I'm not saying that this is not working, but I'm saying that only the product rule is not enough to answer this question. You need 2 rules, the product rule and the sum rule. Okay? We will come to the sum rule later. Okay, but let me, even though this seems natural, let me change the order to see if I can, by changing the order, I can solve the problem. Let me write it here. So let me write S1, the right one, and then S2, the left one. Okay, so it might happen that even if I do this, it might happen that this happens again. It means that, okay, this problem cannot be solved just using the product rule. I need to find a new way for doing it. But sometimes it will work. Let us consider this again. Okay, how many options are available? How many options are available for the right one on the right-hand side? I want to have an odd number, yes?
5.
5 of them. I can have 5 of them. But I am not allowed to to repeat it. Okay, so for example, assume that in the first stage I have done this. I have chosen this. How many options are available for me for the left one? Yes?
8.
8. Yes, why 8? Because I am not allowed to choose this one. I also know that I am not allowed to choose 0. Yes? So how many options are available? 8. But when you want to write 8, do you think this 8 is now independent of what I have done here? Let us check. Assume that in the first one, I haven't chosen 1. Assume that I have chosen 3. How many options are available for stage 2? Are you with me? How many options are available?
8.
Still 8. Assume that I have chosen not 3, I have chosen 5. How many options still? 8. You see, it seems that the number that I am writing here is independent of how I have done the first stage. So you see, is the product rule applicable? Yes. So what is the answer finally? 5 times 8 is 14. Yes. So do you understand what's going on? These are very, very simple examples. I have thought about to design them. These simple examples are actually giving you the important points that you need to remember. You see, sometimes changing the role of stage 1 and stage 2 can help us. Okay, so think about this. And my prediction is again correct. Which one has more limitations here? You see, the right-hand side has more limitation. This is my advice. I'm not saying that it's always working. Yes, I don't have any mathematical proof for that. But if you have something, if a stage has more limitations, my advice is that at least you can start from that. So, is this make sense? This number, how many odd numbers were there? 2-digit odd numbers. Do you remember? There were 45. Okay. Now, how many of them have repeated digits? One of them is 11. The other one is 33. What one? 55, 77, and 99. Yes. These are the only ones that I don't like them now. 1, 2, 3, 4, 5. If I subtract them, how many of them are there? 40. Yes. So I hope that you understood what is going on in the product rule. Okay. But my advice is that you need to repeat these things because immediately the problems becomes very confusing, especially when you start learning about the sum rule and combination of them. Yeah, the problems are actually, yeah. It seems that I'm more excited than you, yes. Now you are making me to a down mood. Everyone is yawning, yes. Okay, what do you want to do for tomorrow then? Are you ready? Yeah. So I don't know. This is the first time that I was very kind. So the exam is very easy. That's from my point of view. Okay. Again, I am telling you that the main theme of the exam, that the first question are 10 functions to differentiate. Okay. I told you before that the main theme is differentiation. So the first question, 10 marks, 10 functions, 10 derivatives. Okay. So very simple ideas. And then and by the way, you are not allowed to have your calculator tomorrow. No calculator available tomorrow. Okay, so there is no question that you need a calculator. Okay, so it means that calculator you need to put there if you have it with you. And please charge your laptops and everything because tomorrow would be very hectic. So please respect these things. And you are not still allowed to write on DG exam. I don't know have they fixed the bug or not, but last time the people who did it in DG exam, the answers were mixed up. So Morten contacted them. They promised to fix it. but I don't know, for some reason, if you have written, I don't know, was it before like it or not? If you have written something very long, I can just see only one part of it. I don't know, was it before like this? So usually people who are very good in typing, they write organized way. So after doing, they go to the next line. But some people prefer to go horizontally. Then I was not able to see the rest of the answer, still now. I don't know, is it always the case or not? Yes? It's always like that? No, but in principle, that if this is going to be like that, the DG exam itself doesn't let you do this. But when it lets you to go on, so it means that there is a bug, yes? They have to fix it. So I think for my exam, please do not write in DG exam, okay? Because if something is going odd, then you have to repeat the exam, and then it would be very hard both for you and for me, okay? Yeah, so let me just end this stream here. Thank you very much. I don't know, 2 are listening here. Okay, so let me end this.